Hello everyone. Today we are going to begin a several class discussion about how we factor polynomials. So factoring polynomials is really an important part of this course, and it's something we're going to use over the next several classes and definitely also over the next couple units. So factoring in general, what does it mean to factor something? It means to express a polynomial as the product of monomials and polynomials. What does that mean? Well, what I've done for us here is taken a couple expressions and I have broken them up into their factored form and their expanded form. Expanded, or sometimes called a multiplied form. This form, okay, the factored form, is basically what we start with and what we've seen in problems before we multiply. So if I had 2x times x minus 5, that's actually called the factored form. And the reason why is because it's broken up into factors. Factors are simply things that multiply together to give you a product. So in this case, 2x and x minus 5 are factors of, if I were to multiply this by distributing the 2x through, I'd get 2x squared minus 10x. This then is the multiplied or expanded form, where this was the factored form. In the next one, we have the product of two binomials, x plus 3 and x plus 1. And we spent some time talking about how to multiply binomials, and we went through three different methods. We said we could use double distribute, FOIL, or the box method. With any of those, when we expanded it, when we multiplied it, we would end up with this answer, x squared plus 4x plus 3. What we're going to learn today is how to go backwards, how to go from our expanded form to our factored form. Okay, and today we're going to focus on how we do a specific kind of factoring called GCF factoring. Over the next several classes, we'll cover all different sorts of factoring. But today we're going to look at problems like this first example here, going from this form to this form. All right, so let's get started. Okay, the first kind of factoring, like I said, is GCF factoring. And that's what we're going to look at today. So GCF is an abbreviation for greatest common factor. The greatest term that is a factor of both original terms. So there is kind of a two-step process when we are looking at multiple terms and we want to determine the GCF, the greatest common factor. We have to ask ourselves two different things. First, we want to look at any number terms. So any numbers that are in common, or any number coefficients that are for any of the terms. And we want to ask ourselves, what is the largest number that can divide evenly into both numbers? Okay, so for example, if I had 2 and 8, I'd say 2 was the largest number that you can divide into 2 and into 8. But if I had something like 10 and 15, well, now I would say the largest number that can divide evenly into both 10 and 15 would be 5. Okay, so that's the first thing, is to look at all of the numbers and to find the largest number that can evenly divide into both numbers. The second thing to look at is your variable terms, so your variable terms. And you have to choose the variable raised to the lowest power. So if I have to choose between a to the second and a to the fourth power, I'm going to choose the a to the second. Okay, so let's take a look at these first two examples. All we're doing is determining the GCF of these first two examples. So the first one is 18x and 45x to the third. So like I said, there's a two-step process. First, we look at the numbers, the 18 and 45, and we say, what is a number that can divide evenly into both 18 and 45? And hopefully we kind of just list through the different numbers that are factors of 18. So if I kind of, some of you are going to be able to do this faster than others, but if you just kind of list through the factors of 18. So I can think about it, I have 1 and 18, I have 2 and 9, I have 3 and 6, okay? And then I look at the factors of 45. So what numbers multiply together to give me 45? 1 and 45, 3 and 15, 5 and 9. Okay, and so if I look at these lists, I'm looking for the largest number that's in common in both lists. And so I would definitely say that 9 is the largest number that's in common. Now, you might have also noticed that 3 is in common with both, but 3 is not the greatest, the largest number. And so 9 is our numeric GCF. Okay, now we want to compare the variables. So my variable terms are the x and the x cubed. Okay, and so between the x and the x cubed, the rule is to take the lowest power. So I would only take out the x. So 9x is the GCF for that first example. Okay, number 2. I have negative 8ab squared and 2ab. So again, first look at your numbers. I have negative 8 and I have 2. All right, this one's a little easier. Probably don't need to make a list of all the different factors because hopefully you recognize that 2 is in fact a factor of both 2 and 8. And so if one of your numbers is a factor of both, it probably is going to be your GCF. So 2 can come out. Okay, now we look at our variables. And this time we have two different variables. We have a, and notice in both of them they have just an a. As long as that a appears in both to the same power, you can go ahead and pull that out. Then between b squared and b, I would again take the 1 raised to the lower power, which is my b. So 2ab is the GCF for the terms negative 8ab squared and 2ab. Okay, so now we're actually going to practice factoring. So what you need to do first of all is determine the GCF of all the terms in the polynomial. Then you're going to write down that GCF, okay? And then you're going to ask, what would I have to multiply to the GCF to get back each of the original terms in the polynomial? Write these terms in a parenthesis next to the GCF. Those are going to be your two factors, the GCF and then this parenthesis with a polynomial inside of it. So let's look at the first one. 15w minus 3v. So first thing is to determine the GCF. So like we were just practicing, between 15 and 3, the greatest common factor, the largest number that divides into both 15 and 3 would be 3. Okay, now look at your variables this time. You have a w and you have a v. They are not in common, and so therefore 3 is the only part of the GCF that you have. You don't get a variable this time. Only a number comes out. Now, step 2, it's kind of wordy, okay? But it's basically understanding that factoring is the opposite of the multiplication process. So you have to undo it. You have to say 3 times what gives me 15w. So I kind of break it down one thing at a time. So 3 times what gives me 15, and hopefully you're all saying, oh, 5. 3 times 5 is 15. Then I need that w there. So if I need the w there, I have to put 1 in. Now check it. If you were to multiply the 3 times the 5w, do you get 15w back? Yes, you do. And so we're ready to move on. Minus, okay, now we have 3 times what gives me back 3. Do you see how these match identical? 3 times what gives me 3? Well, 1. And so you can put a 1, okay, or you could really leave it blank, but we're going to go ahead and put that 1 there. Now again, you have that variable, that v, and that needs to go there. Okay, an easy way to check to make sure you did it right is to go backwards and now multiply. Okay, so if you were to multiply in your brain, don't actually write it down, but if you were to multiply, 3 times 5w is 15w minus 3 times 1v is 3v. And so that's how you know you did it right. Okay, number 2. Let's look at 14c squared and 21c to the 5th. Okay, first look at the numbers, 14 and 21. What is the largest number that divides into both 14 and 21? And hopefully as you're thinking through numbers that multiply together to give you 14 and numbers that multiply together to give you 21, you've thought of 7. Okay, now let's look at the variables. C to the 2nd and C to the 5th. Remember the rule to determine a GCF. is to take the variable to the smaller power. So that would be c to the second, then a parenthesis. Okay, there's your GCF. Now we figure out what has to go in the parenthesis in order to multiply to give you back what you started with, which was this right here. Okay, so 7 times what gives me 14? 7 times what gives me 14? Hopefully you're saying 2. C squared and c squared. If they match, you're done. You don't need to put anything more in. They already match. Minus 7 times what gives me 21? 3. C squared times what gives me c to the fifth. Now let's keep in mind that, remember, in order to, when you multiply powers, when you multiply variables, you add the exponents. So 2 plus what would give me 5? 3. All right, so it must be a c cubed that you had to multiply by c to the second in order to give me c to the fifth. And again, just kind of mentally check to make sure. If you distributed this through, do you get back what you started? Yes, that gives me 14c squared, and these multiplied together would give me 21c to the fifth. Okay, let's go through the next one, number 3. 4x squared y plus 16xy minus 2y. Okay, so again, start by looking at the numbers, 4, 16, and 2. Hopefully we can all agree that 2 is the largest number that divides into all of them. Okay, now let's look at your variables. You have an x squared, an x, and no x in this last term. So because there is not an x here, we cannot take an x out because it's not present in every one. It's not common to all 3 terms. Okay, look at the y, y, y. They all have a y, so go ahead and pull that out. Okay, there's your GCF, now your parenthesis. Now we go backwards. 2 times what gives me 4? And you'd say 2. Okay, we need to have an x squared here, and we don't have one here in our GCF. So that means we have to put all of x squared right there. And then our y's match, so I don't need to multiply any more y's in. It's already matching. Okay, this y matches this y, we're all set. All right, now your plus sign. 2 times what gives me 16? 8. Again, we need this x here, so we need to put an x. And the y's match, so we can leave it alone. Minus. Okay, notice here that this 2y matches this whole 2y. Okay? That does not mean that we just are done. It means that we have to say, well, 2y times what gives me back 2y, and hopefully you're saying 1. Okay, and so if we want to copy that exact thing back again, you have to multiply it by 1. So again, kind of just check through. If you were to distribute those through, do you get this back? And you do, so it's correct. Okay, we're going to do one more together, and then I'm going to ask you to do number 5 and 6 on your own and come into class, and we'll check them together in class at the beginning of next time. So number 4, 56 x to the 4th, y to the 3rd, minus 42 x squared y to the 6th. Okay, 56 and 42 are pretty large numbers. So this might be a place where you want to kind of off to the side list out your factors of 56. Okay, so obviously I have always 1 and itself, the number. Okay, now if I want to determine if other numbers are factors of 56, I simply can use my calculator and try and divide them into 56 in my calculator. So 56 divided by 2, yep, that's 28. 56 divided by 3, no, it doesn't go in evenly, so we're not going to list it down. 56 divided by 4 is 14. Then the last pair that hopefully you know is 7 and 8. So 7 and 8. Okay, so those are my factors of 56. Now I'm going to do the same for 42. Okay, so 1 and 42, 2 and 21, 3 and 14, and 6 and 7. And again, just try dividing numbers into 42 to see if in fact they are factors of that of that number. So if I look through my list of all of these different numbers, what is the largest number that appears in both lists? And I would definitely say 14. So 14, and now I look at my variables. X to the fourth and x squared, what's in common? X squared. Y to the third, y to the sixth, what's in common? Y to the third. Remember, you take the smaller of the exponents. Okay, parenthesis. Now we go backwards. We're asking ourselves 14 times what gives me 56? Well, my list of factors over here is very helpful now because I see that that would be a 4. Okay, now I look at my variables, x squared, and I need x to the fourth. So I already have x squared, I already have 2, I need 4, so I need to multiply in an x squared. Okay, look at the next one, y cubed, and I need y cubed. Well, if they match, we can leave it alone. Minus 14 times 3 is 42. Okay, again, take a look at your variables. X squared, they match, leave it alone. Y to the third, y to the sixth. Okay, look at this. I have 3, I need 6, so I need to multiply in y to the third more. All right, so now what I'd like you to do is pause the video right now while it's fresh in your brain and go ahead and do number 5 and number 6 on your own. Like I said at the beginning of class, we will be looking for them done, and we'll go over them. Okay, we have 2 quick application problems that I'm going to try and get through quickly. If the area of a rectangle can be expressed by 2x squared minus 14x, and the length is 2x, which of the following could represent the width of the rectangle? So let's take a picture, okay, of a rectangle. I have a length is 2x. I don't know what the width is, and I can tell that the area is 2x squared minus 14x. Okay, now let's think about how do we get area of a rectangle from length and width. And hopefully you're saying area is length times width. So what I know here is that I have my area, 2x squared minus 14x. I have my length as 2x. The question is, what must go in that parentheses? Well, if I look at it, if I write it out with a little bit more room here, 2x parentheses what? Okay, this is my length, and this is my width. Well, if I look at my choices here, which one, when I multiply by 2x, am I going to get back the 2x squared minus 14x? Well, I can kind of factor it out. Isn't that what I'm doing? If I take and write it as the product of 2 terms, that in fact would be factoring. So here, if I say 2x times what gives me 2x squared? And I would just need the x to go there. Minus 2 times what is 14? 7. My x's match. And so x minus 7 must be my width, which is choice 3. All right, number 2, last one. In the equation, 32x squared y plus 16xy equals 16xy times parentheses ax plus b, where a and b are integers. Find the values of a and b. Okay, this can get confusing, but we've seen questions like this on the exam. And they're basically telling you, they're giving you an equation where they have given you the expanded form on the left and the factored form on the right. And what you have to do is just fill in what a and b would be. All right? So basically, they've already given it to you in factored form. You're just filling in these missing pieces. So if I were to say 16xy times what would give me back 32x squared y plus 16xy? Well, let's go term by term. 16 times what gives me 32? And you'd say 2. X times what gives me x squared? X. And the y's match, so we leave it alone. Plus 16 times what gives me 16? 1. The x's match and the y's match, so we leave them alone. So if you look here, now this and this are strikingly similar. The only thing that's different is your A has been replaced with a 2 and your B has been replaced with a 1. And so those are your answers after you've factored 32x squared y plus 16xy. A is 2 and B is 1. Okay, thank you so much. Make sure you finish those 2 problems that I left you with, and we'll see you in class next time.